All right, Math 1. So, we're going to talk some more about these sequences. Last time with the growing dots, remember we had the beginning, after 1 minute, after 2 minutes, and so on. Okay. So remember, if you didn't write these down, you need to make sure you get these written down. So a sequence is a pattern of growth with numbers. Okay. An arithmetic sequence is when that pattern is adding or subtracting by the same number each time. Okay. The common or constant difference is the number you're adding or subtracting in an arithmetic sequence, or in other words, the growth. Okay, now we've got two kinds of formulas, or we could even write equations here. So we have a recursive equation. That connects the outputs. Okay, and here's an example. We're going to use some special type of notation for that, and we'll talk more about that. We also have an explicit formula where we connect an input with an output. Okay, an example of that kind of formula. Okay, so we've got about 3 examples that we're going to take a look at, and using tables kind of see how we can understand the recursive and explicit formulas. Okay, and then we'll have some that we'll work on together, and then some that you'll work on your own, and that's kind of the pattern we're going to go with. Now, this needs to be handed in at the end of class. Unless we don't get far enough, then it can be taken home as homework. Okay? Alright, so let's get going here. Okay, so we've got our sequence here. Okay, so we go 4, 14, 24, and then 34. Okay, so when we're dealing with a sequence, this term right here is the first term. Okay, now it's not the 0 term, so this isn't necessarily the starting point, but on our table we want to write it like this. Okay, so that would be our number over here and what term it is. So our first term would be 4. Okay, our second term would be 14. Third term, 24. Fourth term would be 34. So our question is, what kind of growth do we have going on here? Okay. Well, as I go from output to output, we are adding 10 each time. And you should notice that. Okay. Now, with a recursive formula, we said a recursive formula connects outputs. Okay. Another way of talking about recursive formulas is that it's how our mind works. Okay. So if I'm looking at this table, I want to find the 5th term. Well, how do I figure out the 5th term? Well, to do that, we take the previous term, 34, and we're going to add our growth to it, 10, to get 44. Okay? So, as we keep going, we keep doing that same thing. We take the previous term, so if I'm going to 6, we take that previous term and we add 10 more to it, so we'd end up with 54, and so on. We would keep going, okay, until we got to the nth term. Okay, the nth term is essentially, say, what if we don't know which term we got to? Okay, now the recursive formula, it works like this. We're saying to get the next term that's equal to that previous term. So right, when we were going for 7 and we wanted to figure that out, we took the previous term, and then what did we do to it? We added 10, or we added the growth to it. Okay, that's what a recursive formula looks like. Okay, to get that next term, we take the previous term and we add the growth. Okay, so when we're looking at this, okay, when we try to figure out this formula, this nth term, what we have to end up doing is we have to use some different format of writing. So instead of next term, we're going to write a sub n. Okay, that n represents the number over here. Okay, this term is n. A means it's a sequence. So a sub n equals, now the previous, Okay, this is where it gets can be kind of confusing. Okay, so let me clear this out a little bit. So we had 34, 44, 54. So I want to find the nth term. Now the nth is just a variable, like I said, so it could be any number. Okay, but we don't know what number it is. That's why we need the formula. Okay, so to find the nth term, what we have to do is we have to jump back one. But if we don't know what the nth term is, we don't know what the previous term is. Okay, so we call that the n minus 1. Okay, because we're jumping back a step. We're subtracting 1 from n. If n were 8, the previous one would be 7, which is 8 minus 1. If it were 800, the previous would be 799. Okay? So that previous term, okay, is what we call a sub n minus 1. Because we're working backwards to figure this out. Okay? Then our growth, that's usually the easy one. It was plus 10, so we add 10. Okay? So I have a sub n equals a sub n minus 1 plus 10. And when we're dealing with recursive formulas, this a sub n minus 1, basically that doesn't change. Okay? That gives us, we just put our growth on there. That's really the only thing we change. Now, the problem is, okay, our plus 10 was the growth. Okay, but we didn't get our starting number. Okay, so right now, if I look at this arithmetic formula, I don't know where I'm starting. I know I'm adding 10, but how do I know I'm going to be 14? Now you may say that we're starting at 4. Okay, but notice 4 is actually the first term. So I could go a sub 1. Okay, that 1 comes from that being the first term, equals 4. 4 being what that term is. Okay, I could write it that way. There's another way I could write it as well. Because normally, when we have a starting number, our starting number is what we would call the 0 term. Okay, so the 0 term, so if we're going backwards, the 0 term, we would subtract 10, right? So 4 minus 10 would be negative 6, because negative 6 plus 10 gets us back to 4. So we could also write, instead of a sub 1, a sub 0 equals negative 6. Okay? Now, this 0 term becomes important when we're dealing with what we call the explicit formula. Okay? Which we're going to talk about that as well. But for right now, we'll need this and then either one of these guys. Okay, I would get in the habit of working backwards to get to a sub 0, or in other words, our starting number, because that's going to be very helpful. Okay, now let's talk about let's do a few more examples with recursive before we jump to explicit. So let's look at this sequence. So I've got 1, my first term is 50. My second term is 45. My third term is 40. Fourth term is 35. Okay, so we should have a pretty good idea of where we're going with this. Okay, we're subtracting 5 each time, right? That's our growth. So, for my recursive formula, I'd go a sub n equals a sub n minus 1. And then we're subtracting 5. But where are we going to start? What's our a sub 0? We could do a sub 1 equals 50. But we want to get in the habit of going back here. So what would be the term previous to 50? It would be 55. So I'd go a sub 0 equals 55. Okay? And that's just how easy the recursive formula is. Notice that this and this piece are the same as they were here. The difference was my growth and my starting number. Okay, we talked a few days ago about the importance of that growth and starting number. Okay, here's where we see it again. And that's our arithmetic or recursive formula for this arithmetic sequence. Okay, now let's take a look at this one. So I've got my first term is negative 18, my second is negative 9, third term is 0, fourth term would be 9. Okay, hopefully we can see we're adding 9 each time. So my fifth term would be 18, and my sixth term would be 27. So now if I'm going back to my 0 term, we'd go backwards and say what plus 9 equals negative 18? It would have to be negative 27. So now we're trying to figure out what our n term is, our nth term. Okay, that's our formula. Whenever it's asking for the nth term, it wants a formula. So just like always, I go a sub n equals a sub n minus 1. I'm also going to go a sub 0 equals something. So here is where I put my growth and my starting number. So what's my growth? Well, we decided we are adding 9 each time. And what's my starting number? Well, my starting number was negative 27. With that information, I've got my recursive formula. I know now how to build this table and how to find this pattern. Okay, so we're going to take a look, and let's pause it for a little bit and see if you guys can find that recursive formula with this one. Okay, so take about 5 minutes. Actually, you probably don't even need 5 minutes. Let's take just 2 minutes here and see what we can get. Alright, so hopefully you were able to do this one. We'll have some more time to work here. Okay, so let's say, okay, do we know our starting point? If you put negative 37, you're wrong. Remember, that's our first term is negative 37. Okay, our second term, negative 7, third term, 23, fourth term, 53, fifth and sixth term. Our fifth would be, what's our growth here? Well, it might be hard to see, but negative 7 to 23, we're actually adding 30. 23 to 53, we're adding 30. So that common difference, or our growth, is adding 30. Okay, so this would be 83, this would be 113, and now we want to find this recursive equation because that'll tell us what the nth term is. Okay, so I go a sub n equals a sub n minus 1 plus 30. But that's not my complete equation. We need that starting number, don't we? So going backwards, if I subtract 30, it would be negative 67. So my starting is actually negative 67. Okay? And it would look like that. Alright, let's give ourselves another 2 minutes here. We'll come back to the explicit, but let's take a look at some recursive equations first and see where we can get from that. So now what I want you guys to actually do is I want you to do question 2, 3, 4, and 5. Let's see, 4 is down here, huh? Okay, so questions 2 through 5, give ourselves just 5 minutes for this, okay? So 5 minutes, ready, set, go. Alright, so let's see how we did here. Okay, so we're just doing recursive, remember. So our first term was negative 23, our second negative 14, our third negative 5, our fourth was 4. So how is this growing? Well, we're adding some number here, aren't we? Negative 23 to negative 14, we would be adding 9. Okay, if you weren't sure, just go negative 14 minus negative 23, you'd get a positive 9. That would give us negative 5. 4, adding 9 here, would give us 4 plus 9, would give us then, well, having troubles here. 13 plus 9 would give us 22 for our fifth and sixth term. So if we go backwards to our 0 term, it would be negative 34. So our starting point, negative 34. Our common difference, we're adding 9. So our recursive, a sub n equals a sub n minus 1 plus 9. And a sub 0 equals negative 34. You could have also put a sub 1 equals negative 23, and that would still work. Okay? Alright, 3. First term, I'll just write these down first. Okay, so negative 31, negative 21, negative 11, negative 1. So it looks like we are adding 10 here. So this would be positive 9, then 19. So our common difference is we're adding 10. So a sub n equals a sub n minus 1 plus 10. Going backwards, this would be negative 41, so our starting point, negative 41. So a sub 0 equals negative 41. Okay, now number 4. In case you didn't stay caught up with me, but you should have all this already done. Okay, so 0, 1, 2, 3, 4, 5, 6, n. Okay, 30, 34, 38, 42 should be pretty easy to see that our growth is plus 4. So a sub n equals a sub n minus 1 plus 4. Remember, this is the next term, that's the previous term. Okay, if we go backwards, we'd have 26 for our starting. So a sub 0 equals 26. Okay, and that would be what, 46 and 50. All right. Oh, yeah, it was number 4. Okay. Now, number 5 is as far as we should have got, so 0, 1, 2, 3, 4, 5, 6, and n. So we have 3 is our first term, 203, 403, 603. Hopefully we can see that would be 803 and then 1003, so we're adding 200 here. So our common difference is 200. So going backwards, 3 minus 200 would be negative 197. That's our starting point. So we get a sub n equals a sub n minus 1 plus our growth. And our starting number, a sub 0, is negative 197. Alright, so now we've got 6, 7, 8, 9, and 10. So 6 through 10. Let's give ourselves 8 minutes and get these ones done in 8 minutes, okay? Alright, so hopefully you got all the way to 10 done. Okay, so if we can see here, we're subtracting 6 each time. So our common difference was minus 6. So a sub n equals a sub n minus 1 minus 6. Then our starting number, a sub 0, we go backwards, that would be 38. And we get 38 here. And if we finished our table, we'd have 8 and then 2. And then n, remember, is that whole piece. Okay. Alright, if we're looking at number 7 now, okay, we've got it right here. So we can see we're adding 3 each time, so our common difference is plus 3. Going backwards, that would be 24. So our starting point was 24. So a sub n equals a sub n minus 1 plus 3. And a sub 0, our starting point, 24. That would be 39 and 42 if we kept going. Okay? Alright, number 8. Okay, we can see that we're subtracting 2 each time, so negative 45, negative 47, going backwards, negative 35. So negative 35 is our start. Subtracting 2, so we get a sub n equals a sub n minus 1, right? The next term equals the previous term plus our growth, which was minus 2, which I need to write that a little better. And then our starting number, a sub 0, not a sub a, equals negative 35. Alright, now number 9. You should have seen you're subtracting 5 each time, so negative 32, negative 37, going backwards, negative 7, so start of negative 7, common difference of negative 5. A sub n equals a sub n minus 1, minus 5. A sub 0 equals negative 7. Okay, then number 10, we're adding 7 each time, so 29, 36, going backwards, negative 6. So start at negative 6, common difference of add 7. A sub n equals a sub n minus 1 plus 7. A sub 0 equals negative 6. Okay, so now on that last page, you're not going to start it now, but you've got 6 more problems to do recursive ones for. We're also going to do explicit. So let's go back and take a look at our original examples, and let's see now how we can get that explicit formula. Okay? It'll be pretty interesting how we go here. Alright, so let me erase a few things. So the explicit, as we said, that connects an input with an output. Okay? The recursive formula is great for building a table and great for understanding the growth and where you start. But you don't want to keep going down here to find the 100th term. Okay? So we want to connect these numbers this way. Okay? Recursive connected them down here. We now, using explicit, want to connect them across. Okay? And the way we think about it is like this. So our growth here was plus 10. So the way we think about it is like this. So we start out at negative 6. Okay? This term we didn't add 10 to it. So it's negative 6. But this next one, this first term, we started at negative 6 and we added 110, which gave us positive 4. At the second term, to get to 14, we start at negative 6 and we add 10 twice. Okay, giving us positive 14. At 3, maybe you're seeing a pattern here. We started at negative 6 and we added 10 3 times. At 4, started at negative 6, added 10 4 times. At 5, started at negative 6. To get to 44, we have to add 10 5 times. And finally at 6, we added 10 6 times. So now my question is, okay, and this gave us 24, 34, 44, and 54. So now here's our question when we're talking about our equation here. Okay, what if I go to the nth term? How many times are we adding? Well, hopefully you noticed this. 0 term, 0 tens. Term number 1, 1 10. Term number 2, 2 tens. Term number 3, 3 tens. 4, 4 tens. 5, 5 tens. And then the last one that we had, 6, 6 tens. So n should have how many tens? N of them. But we don't know how many that means. Okay, so how do we write that? How do we deal with that? Well, let's think of it this way. Okay, let me erase these. And let's do this. Negative 6, we said we added 0 tens. Okay, so this one we added 1, 2, 3. What's another way I can write 10 plus 10? How about 2 times 10? And this one, how about 3 times 10? Isn't that multiplication just repeated addition? So here we would go 0 times 10. Here we went 1 times 10. And then 2 times 10. And then 3 times 10. And 4 times 10. And 5 times 10. And 6 times 10. So n would be n times 10. Okay? So, see how this is our input numbers. That's how we connect the input to the output. Okay? Now, we like to rewrite it, negative 6 plus 10n, but that is our explicit equation. Okay? Now, we could write it like y equals negative 6 plus 10x, same thing. We could even rearrange it and go 10n minus 6, same thing. Okay, so let's take a look at this one. All right. So as we're looking at this one, same idea. We start at 55 and we subtract nothing. The first term we subtract 5 once. Okay, so this would be like 55 plus 0 times 5. This would be 55 plus 1, actually minuses, huh? Not pluses, because we're subtracting minus 1 times 5. This would be 55 minus 5 minus 5. 55 minus 5 minus 5 minus 5. Do you see the pattern? You should. Okay, so this would be 2 times 5. 3 times 5. 4 times 5. then 5 times 5, then 6 times 5, till we get 55 minus n times 5, which we'll rewrite as 55 minus 5n. That would be our explicit equation. Notice we don't have any a sub n minus 1 because we're not dealing with the previous. This n stands for that guy. Okay? So let's take a look at this last example. So negative 27 didn't add 9. Negative 18 we add 9 once. Negative 18 we add 9 twice. Negative 18 we add 9 3 times. Negative 18 we add 9 4 times. Negative 18 we add 9 5 times. And negative 18, oh crap, not negative 18, negative 27. How come you guys didn't tell me I was making a mistake here? Because we have to do that starting number, not our first term. Okay, so then using that repeated addition trick, which is multiplication, we go plus 9 times 0, plus 9 times 1, plus 9 times 2, plus 9 times 3, 9 times 4, 9 times 5, and 9 times 6. So we get a sub n equals negative 27 plus 9 times n. Alright, so now what I want you guys to do, for questions 1 through 10, okay, I want you guys to write out the same thing. Okay, and the reason I'm having you write it out is so you really hit into that pattern. Okay, we're almost out of time here on my video. I can only go for 30 minutes. So I'm going to fill these out for us, and then we'll just go through really quick and talk about them. You guys can check your work. Give yourselves, probably for this one, let's give ourselves about 15 minutes, 15 to 20 minutes as needed for these last problems, okay? And then we'll go from there. Alright guys, so I don't have much more time on this video to show you, but the thing you should notice is whatever the input value is here, that's how many of the growths we have. We should see those same input values. So for n, you end up with, for your explicit equation, a sub n equals negative 67 plus 30n. For number 2, same idea. We see the same pattern. Okay, same pattern for the explicit. A sub n equals negative 34 plus 9n. Now, had you went a sub n equals 9n minus 34, same thing. I would accept both of them. Okay. 6, well, page 6 on here. Number 3, we had all the 10s. See the inputs, negative 41 plus 10n. Okay, same with number 4. A sub n equals 26 plus 4n. Okay, same pattern here with the inputs. Should have got so tired of writing these out because you just saw the same exact thing. Okay, so a sub n equals negative 197 plus 200n. Okay, a sub n equals 38 minus 6n for number 6. Same pattern. Okay. 7, 24 plus 3n. 8, negative 35 plus 2n. Okay, 9, negative 7 minus 5n. And 10, negative 6 plus 7n. Once again, the inputs are connected to the outputs by that same thing right there. Okay, that pattern we see going down there with the inputs. Because we're adding, and repeated addition is multiplication, so that's why we end up with multiplication even though the pattern is adding. So you've got these 6 problems to do. If there's any time in class, get them done in class. If not, take this home and get them done at home. You also have an assignment, 1.2, that you need to make sure you grab before you get out of class, and try to get those done, both of them, by next time. Okay? So there you guys go. You should be able to take a look at these, find the growth, find the starting number, write the explicit and the recursive equations for me, and then when we come back tomorrow, we'll just keep going with this kind of stuff. All right? So get those done. Get any homework. We've got the homework piling up, so get it done, guys. Anyway, that's pretty much all we got. So we'll just let the time finish to 30.